In this video, we're going to be looking at the change, delta f, the value of the estimate, and the approximation error. So the change will be f of x naught plus dx minus f of x naught. The value of the estimate will be the derivative at x naught times dx. And the approximation error will be the difference of those two, and then the absolute value of that. So let's look at the first example. I'm given f of x equals x squared plus 2x, where x naught is equal to 1, dx is equal to 0.1. The derivative of f will be 2x plus 2. So now to find the change, delta f, I want to add x naught plus dx, and then minus f of x naught. So if I add x naught with dx, that's 1.1, and I'm going to subtract that with f of 1. So I plug this in the calculator and I get the difference, or the change, is 0.41. Next, I want to look at the value of the estimate. So I'm going to be looking at df is equal to f prime of x naught times dx. So x naught here is 1. So if I plug in 1 in the derivative, I get 4. And dx is 0.1. So that would just be 0.4. Finally, the approximation error will be the difference between df, or delta f, and df, which will be 0.01. Next example, f of x is equal to 2x squared plus 4x minus 3. X naught is negative 1. Dx is 0.1. So the change, we'll call it delta f, is f of x naught plus dx minus f of x naught. Here x naught is negative 1, and so I'm going to be adding negative 1 with 0.1 to get negative 0.9, and then minus f of negative 1. Plug this in, I end up getting 0.02 as my change. Next, I want to look at the value of the estimate df, which is the derivative at x naught times dx. This one I need to find the derivative of f, so that would just be 4x plus 4. So I'm going to plug in x equals negative 1 into the derivative, and so I'm going to get 0. And I don't care what dx is, because when I multiply that by 0, I get 0. So the value of the estimate is 0. Finally, the approximation error will be the absolute value of delta f minus df, and in this case is 0.02. Next is f of x equals x cubed minus x. X naught is 1. Dx is 0.1. It's good to take the derivative in this case, just to get it out of the way. The derivative is just 3x squared minus 1. The first thing I'm going to be looking at is the change, delta f. And that's just going to be f of x naught plus dx minus f of x naught. In this case, x naught is 1, dx is 0.1, so that would be f of 1.1 minus f of 1. So we plug this in, and we get 0.231 as my change. df will be the derivative at x naught times dx. So the derivative at x equals 1, if you plug it in, you get 2 times dx is 0.1. So the value of the estimate is 0.2. So the approximation error will be the absolute value of the difference of delta f and df. And so in this case will be 0.231 minus 0.2. And so the approximation error will be 0.031. Next, I'm given x to the fourth, where x naught is 1 and dx is 0.1. I'm going to find the derivative first, which is 4x cubed. Then I'm going to be looking at the change, delta f, which we said is f of x naught plus dx minus f of x naught. X naught is 1, dx is 0.1. Plug that in. So here we get 0.4641. And that's the change. The value of the estimate df will be the derivative of f at x naught times dx. The derivative, if I plug in x naught equals 1, so plug in 1 in the derivative, I get 4. Dx is 0.1. So the value of my estimate is 0.4. Finally, I'm looking at the approximation error. So if I plug that in, I look at the absolute value of the difference, and I get 0.0641. That's my answer. All right, next problem. We have f of x equals x to the negative first power, where x naught is a half, dx is 0.1. My derivative using the power rule is negative x to the negative second power. I'm first going to find delta f, which is my change. So that would be f of x naught plus dx minus f of x naught. So x naught plus dx, that's a half plus 0.1, which is 0.6 minus a half. So plugging this in the calculator, I end up getting negative 1/3 as my change. Okay. Next, we'll be looking at the value of the estimate, which is the derivative at x naught times dx. So x naught is a half, so I'm looking at the derivative at a half, times dx, which is 0.1. So I can rewrite f of f prime as negative 1 over x squared. So in this case, it would be negative 1 over half squared times 0.1. And that's the half squared is 0.25, which is negative 4 times 0.1, and that's going to be negative 0.4. Notice my change is in a fraction form, so I'm also going to write my value of the estimate as a fraction, so that'll be negative 2/5. Because when I look at the value or the approximation error, I'll be taking the difference of delta f and df, which in this case is negative 1/3 minus negative 2/5. The two negatives make it positive. And so if I were to subtract these, I get, let's see, 1 over 15. And so the approximation error is 1 over 15. Okay, finally, I'm going to be looking at f of x is x cubed minus 2x plus 3. X naught is 2. Dx is 0.1. The derivative is 3x squared minus 2. The change delta f will be f of x naught plus dx minus f of x naught. So x naught plus dx, well, x naught is 2, dx is 0.1, so that would be 2.1. Plugging this in the calculator, you get 1.061 as the change. Next, we'll be looking at the value of the estimate. So df would be f prime of x naught times dx. So x naught here is 2, so be looking at the derivative at x equals 2. And then times 0.1. So if I plug it in, so 2 squared is 4 times 3 is 12, minus 2 is 10. So it'll be 10 times 0.1, and that's just 1. So here at df, the value of the estimate is 1. Finally, I can look at the approximation error. So here I'll just be subtracting. So I get 1.061 minus 1, which will be 0.061. And that's my approximation error.